Hello and welcome back to another session of Google.rs. It's Byron speaking, and we are back with cargo. And in fact, we would have to do one of these things. Yesterday, we set up some tests, which basically allows me to do something like this. So if we delete our local cargo home and start fresh, you'll see that for the most part, it works. It now works for updating the registry, and it works for downloading items or crates into the registry. But it doesn't yet work for repositories which are mentioned as, see, this is the multi-threaded one. So they try to compete now for the download, but the one realized, well, it's locked and I'm going to verify it instead. Yeah, so I don't really know how this is actually working, because what's this guy doing in the meanwhile, right? So I don't know. They never, I would expect that if they're competing for the same stuff, that, oh no, wait, maybe the download realizes that the crate already exists before they compete. I think this is why you see this. And this verifying might be something that we don't even want to show, because people would be confused about that. Yeah, just fanciness for me to see that. But I think that's the first thing I would want to cut, because hey, why is it verifying this now and not, what is this? So let's kick it. Let's kick the verification and state it why we kick it. Don't print verifying status on competing downloads. It's primarily cool to see that there is competition or concurrency going on, but the user shouldn't have to care. Yeah, I think that's primarily it. We will, in most cases, there is no concurrent or there's no attempt to concurrently download anything, as the crate will already be present. I think that's it. Yeah. So we don't want to show this. Yeah, maybe I will also add a link to a gist here. No. Wow. Oh yeah, that's 5,000 branches that have been created here. Kills my entire history. Crazy. So that's very interesting too. Here's my gist. What is it? It's concurrent concurrent cargo with a newly created registry. Create public gist. There we go. And sure, I think I will even shorten this URL. Here is an example on how it looked previously. There we go. Here's an example. I think I just want to use markup here and markdown. So cool. That is that. And we are done. So again, what we want to do is make this work, right? Because that fails right now. And for that, we have to lock the compile process somehow. And yeah, there are a few things to worry about. Yeah, so there's the CargoLock file that is created for the current package. And yeah, let's see what else there is. And there are fingerprint files that can be competed on. But ideally, we just lock the entire package compilation so that everything else is naturally locked as well. And compile targets would be the right thing. So what is this? High-level worker which initializes structure and schedules plenty of work. It's called by compile package. This is what needs to be locked. This is what needs to be locked per target, as there can be multiple cargos building different things with shared dependencies. Yeah, so this is basically what we want, and compile package. Compile package will probably resolve package will trigger updates and downloads, thus locking CargoLock will be necessary. Yeah, so this should also be done here somewhere. And I think this lock update as locking could be done here. Load lock file, write lock file. So now we can start using shared locks as well. Possibly, even though load lock file will fail if there is no file yet. So yeah, we could either, if there is a CargoLock file, we can get an exclusive lock on that one in case we want to write it. But the problem is that figuring out if there is a lock file or not will unfortunately be a race right now. So we would always need our own distinct file, or we use CargoLock. No, wait, actually, we will use CargoLock. And we could create it in an empty fashion. Or we could use this mechanism, to actually write into this file that the lock created for us. That's how we want it, because then we are good. We just have to see that this actually works. Yeah. And yeah, for now, I'm going to, let's take care of this compiling the same targets concurrently. So that's compile targets. Let's look at this. Compile target. And yeah. It actually isn't super easy to figure out what we want here. But yeah, so context prepare, this will create directories for us. And here all these prepare methods, they create structure, which obviously can fail if it's done concurrently. So here we would need a lock already for our package. That's the main package. Returns a mapping of the root package. So that's where we start. So basically, if we start here, it would be good. And also compile pkg is what runs compile targets. So maybe we can lock the primary package here and maybe even provide the lock file along with it. Let's see what we want to do here. So wait, compile pkg. This one should be locked in case there are concurrent attempts to build a target. Resolve pkg, called by various sources. I think resolve pkg comes down to dealing with the lock file stuff. And actually, with shared dependencies. What am I supposed to lock? Compile targets. Okay, so compile targets is what I'm supposed to take care of, but resolve PKG and all this stuff, we will have a look. Resolve PKG, after all, is called by cargo fetch as well, so we have to do locking on a more fine-grained level, right? Where does it do? So here it gets the package dependencies, generate targets, and then compile targets. This is what it comes down to. All right. So here's where we want to be. Context prepare. CX is a context. Let's close a few files. Registry we don't need anymore right now. This is fine, I think. This we don't need right now. Multi-rest we definitely don't need. Flock, no. Errors, no. Lib, I don't think so. Here, no. Manifest. We'll just reopen stuff we might need. Lock and notes we can keep, even though lock even is not required right now. Good. So that's better. So let's bring up another tab here. With prepare on context. Here it is. Prepare this context, ensuring that all file system directories are in place. C. And this can totally fail. It prepares. So wait, where is it? Compile target. Here's compile targets. Oops. So yeah, does it on multiple targets? Yes. It's a slice of tuples of target profile pairs. So each target gets a prepare call. And I think this is where we want to throw in a lock on the root of the target so that it can create itself. And we spill a lot of locks here. And I think this target, this lock we could also use right away. Yeah, we might have a lock folder at some point, possibly. Right now we don't. Maybe to collect all the log files in one place and not throw them around in the file system. But for now, I'll just throw them as close to the structure that it locks as possible. So the build directories, I think this is what target, we have a profile as well, so this is what target debug I think is gonna get, and then depth stuff. On the other hand, we don't really care about this because it's build related. Build requirements. Yeah, would be interesting to know if build requirements does anything with the file system. Build script profile, not directly, not that I would see. It's just this one implementation. Okay. Layout, self layout. Yeah, that's also interesting. Or if that creates something, it creates layout proxies, which I don't know. Do they do anything? Outdear build, outdear examples. Okay, so the layout just provides access to the directories. Layout proxy. Let's have a look at layout proxy. Contains a layout. So FS, any FS activity? Prepare. Yeah, prepare does it, creates directories. This is something we could lock. Self root, probably it gets initialized with root, so we might be able to lock it on a higher level. I want to lock as high as possible. So prepare probably is it. Huh. Self layout. Yeah, for each target it calls prepare. For host it calls prepare. What is host? Is a layout. Okay. So in a way, so there's no FS activity here. So this one is something we wanna lock. I might have to lock it here. Because I don't know about the root directories that are used here. No. But that's definitely a location here to keep in mind. And then we have a prepare call on the target. What is target? Is it also a layout? Oh no, target is a target. Let's see how many prepare implementations we have. Contexts. Nope. Nope. Also nope. Interesting. So it must be... Is this a target for him? Where is struct target? Maybe it implements a trait of some kind that I didn't see. So this is what it would be, huh? Target. Why don't I see prepare anywhere? Why does this call work? Maybe I got it all wrong. Match itself target. It's not the targets that we get here. Okay. So probably I got it all wrong. Didn't I check if target exists as a field on the struct? Yeah, probably I did check. Ah, see, it's a layout. Okay. On the wrong track. Totally on the wrong track. Good. So considering that so many different spots here, we have host layout, we have the target layout. Is there some common root directory that I can use to just lock all of these related things? And probably you don't want to, I mean, how does the prepare work? It checks if the root is there and creates it. Then it tries to make dir on all of these. And it creates them conditionally. So if it's not there, it creates it. So basically, we would be fine locking the entire thing here at the common root. And then even though the effort will be duplicated, it will not fail. But I would rather do this instead of putting a lock here that will possibly create many, many log files which don't really know what they are made for. Oh, look here. Depths, native, build, fingerprint, examples. So this is, let's look at it. LL target debug. That's exactly that. This is what it does. This is the prepare for each target. I don't know if they're this. So that's the only spot where this is used. It sets up build requirements. And I would be surprised if that wouldn't do some file system activity at some point because we have so much more going on here. Depths, for instance. Oh, okay, that's where it puts stuff. Native. Let's look at it. So here we have rlibs. I'm interested in the directory structure. So this stuff, build script, I think that's created in the build process, even though this is a folder that might potentially be created by the build requirements. Is there any FS activity here? No. So apparently nothing happens. Yeah, so again, you would just need to lock the common root, which is debug. I think this is something we created beforehand. And then we, well, maybe not, because it creates, yeah. How do we initialize this context? I think that's quite an important question. Compile pkg, do we have a context? Not here, good. Here we have it. Resolve, sources. Yeah, let's see how you are created. Where is your root? Because these layouts are created with a particular root, right? New config. It has a root, which is a path buff. Where are you set? So here you can create one, add a path, triple, optional string. Huh. So how does it create these? Layout. Interesting. Apparently the context doesn't create these layouts. How come? Is it really? Yeah, it's receiving them. Okay. So yeah, compile targets. Here it does the whole, okay, I'm blind. Host layout, target layout. Build config, request the target as ref, map target layout new. So here, that's always the common root, right? So here is where we have to lock it. I think that's what has to be done. Yeah, also I should be able to schedule the upload now. So let's do it then. The root will be debug. And I think what we can do is just try to find a name that is unique so that we don't kind of lock on the wrong resource accidentally. Build config release dest. Dest. How is dest used? Aha. So that's also part of the layout. So if we use just the root, we wouldn't go into the right folder, I guess. What's the dest? Oh, look. Path push. So he does new there. So that's, yeah, so actually we end up, we should probably ask for the root here. To know where this stuff is going. And there we can then probably somehow, yeah, that should be unique, right? So we can just drop a generic package dir. Build fingerprint. Yeah, I think for this purpose here, it's enough to lock on the root path. We can just query. Oh, we can query it on a proxy. Oh. Damn it. Can I also get the root here somehow? Self root is error. So I want to have this path, right? This root. How do I get it? Ah, dest. So dest is root. Good. So here I want to drop my lock. Now I got it. Because, you know, we could make an assertion here. Assert. Host layout dest equals target layout dest. Well, maybe it fits here. We lock both with one lock file. This wouldn't work if these are not the same. So here's our assertion. Maybe a debug assertion will do. Assert debug. I'm always forgetting, is it assert debug or is it debug assert? Debug assert? Debug assert, it is. Okay, cool. So that is that. Now about locking. CargoLock. Oops. Wrong registry. Really? Huh. I just want to copy some code. Yeah, that's the wrong registry. Not in core. CargoLock. Let's get some standard code. So that's kind of the standard pieces that we need here. This could actually be a macro if you wanted to, because it's very similar all the time. Yeah. So before we try to prepare anything, context resolution is put on the queue. Prepare init, it's also put on the queue. But context prepared, this is preparing the initial directories. And this is what we want to lock, right? Here, this is called right away. So here we need a lock. Oh, actually. I think this check that I put here, I want elsewhere. So host prepare, target prepare. Here we need a lock. And this check needs to be in context. So that we can definitely, actually this guy can't assume that, unfortunately. But we can reuse the same lock and drop it very quickly. I think this is what we can do. Also, subdirectory creation. So these guys, they can only create dear all. This is the critical point, because I think he will provide, at this point we only have the target directory at most, probably not even that. So we create intermediate ones like debug and release, which is controlled here. Yeah. I think considering that, I would like to undo what I did and rather put that stuff here. Because here we know that we should create the root ourselves here. Because then we know that we can create the lock. And on failure, so this is something we compete for. So this intermediate, how do I do this? This intermediate direct. So the initial creation is kind of a critical phase. It's difficult to compete on it, but it will happen at some point. So we should try to be safe here. And previously, what did I do? I dropped the lock in the cargo home because right now we know that this exists. We could lock the same resource. Damn it. Yeah, this target directory, it does not exist at this point. Unfortunately. Yeah. Okay, you know what? Let's panic here. Oh. Let's see what we have. And I will clean out the cargo home and target directory. Rebuild this guy. Hopefully that works. And then try this again, just to see how far we get in terms of folder structure initialization. Because I think the only thing we have until that point is, the cargo home, basically, because that's part of the registry creation mechanism. And this is something, wait. In the lock code, what we put in here, for that very reason, we put in code to create, that's RACI code here, because it tries to create the directory leading to the lock. So in theory, we could put the lock where you want it to be and be fine. Fine in terms of we just try to create the directory. Maybe even a few times if that is too unsafe. Yeah, damn it. But this is where it is actually our safety net here, which we seem to need to do anything, because a cargo home, for instance, when creating the registry for the first time, doesn't exist. And the registry code always just does a create dir all. And when we fetch the lock, we do the same thing. We just create dir all, which can fail. This is why we don't care for failure. But in theory, if two people are trying to do that at the same time, and it's more than one directory that they're creating, then this one will fail and stop, while the other one might still create subdirectories. And then the lock acquisition will fail as well, unless this guy waits on error for the other operation to complete. So maybe this is something we should implement, and then we would be good, right? Yeah. Yeah, maybe we have a try once, if failure, sleep a moment, try again, and fail. Well, maybe not fail, but fail loudly then. Yeah, maybe you should do that. We fail with a human error again. I think this would be something. So did we finish this? Oh, damn it. No method dest found on... Oh, it's an optional layout. Damn it. Host layout. So the target layout was the problem, huh? Yeah. Well, fine. That's optional. Damn it. No, so I can't assume it's there. It's optional for a reason. Damn it, you. Okay, I can't work like this. I have to do it. I have to log on library, on layout, and in the layout itself. Well, that's how it is. Which will always create the top level structure anyway. Yeah. Damn it. But the good thing is, with a little bit of improvement, here, I think this can be far safer. So let's match on this. If it's okay. Actually, I don't know what it returns, but probably nothing. If it's okay, we are okay. If there is an error, we might compete to create one or more directories here. Most of the time, yeah, directories here. Give the competing process some time to finish. Then we will retry, hoping the creation works. Maybe just because the directory is available already. Yeah, so this is how we are going to do it. Use std thread sleep ms. I think that's here. So we sleep for like 100 milliseconds. So that should be enough on a rotating platter to create like 10 directories. It should be totally enough. And on an SSD is even faster. On a network file system, it could be slower though. So yeah, could be a problem. But we will take care. Path unwrap create dir. And we just do the same thing. Let lock dir be this. Let's be specific about it. And now we try the same thing. So if that, actually we are only interested in the error case, right? If let error, then we do this and we try again. If let error, then we will fail loudly with a human error. Return human format. Oops. Fail to create directory Failed to create parent directory of log file ads. Yeah, let's give it a new line here. Actually, like this. And like that. Of log file add here. And then we can just use the display function, log dir display, to display it. And we are out of there. So I think that's a bit safer, even though, yeah, I think it's safer. Even though everything with sleep is error prone. Fail permanently if it still didn't work. Actually, we want to keep the error, IO error, and say IO error, chain error. Yeah, I wanna convert it into a cargo error, and then I can chain the error, right? Is implemented for cargo. Why is it chain error? That's interesting. Here, so impl chain error for that, impl cargo error for chain error. And human returns something. Yeah, so on cargo error, I can on cargo result, I can do a chain error, right? Chain error for box cargo error. For option T. Yeah, I could do the conversion myself. This is an IO error and I actually want to use it and chain stuff there. How do I do that? Human. Cost human, look at that. That's the one. Yeah. Cost human. And now we have even less space. So this is this one and cause E, where this is error. Yeah, we might have to box it to get the static trait going. But, oh, look, some box new, cause. It's boxing it for me. Yeah, let's see. So we start with the error S. And then we just give him the IO error. That should be working. Cool. So let's see how that works. Make. Probably not at all, but we will know early. Human, cost human. Does it work? Cannot borrow self in as mutable because it is also borrowed as immutable. Ha! Ha. Sure, that all works on references. Yeah, I guess the only way around this is to have another scope, which will put everything to the left even, to the right even further, giving me even less space, and yeah. Damn it. This is annoying. I would totally work without word wrap here in this case. Oh, it's just 2 spaces. I don't know. Is there a better way to do this? Because we have to return here. I can't use closures and map functions on result types and whatnot. Okay. So far, it seems to be working. Awesome. Good. So with that in place and in mind, we can have a look at the layout again. And basically, you notice create dir all. This is where we want to create the lock. And we want to get a write lock because so what do we want to do here? Usually I always had create a write lock. And right now there could be actually contention on this. Yeah. So this is racy here. If I would allow this code to happen, then we know it's racy. It's kind of the same thing as it does here, even though that piece of code tries to be very resilient in that regard. You know, and this magic number. To do st find a better magic numbers, especially in sleep, are prone, will fail. They will fail. Will fail at some point. Yeah, what else to do? There's no, there must be a better solution. Maybe smarter people will figure that out. I hope so. So here I need a lock. I will run the create dir code. That will then still make this piece of code work. Then it will try to make dir, which is, yeah. So I think here is where we need it. Long story short, that's where we need it. Maybe find a name for that layout as well. So util cargo lock, please. Thank you. fs. It's only here, right? Cool. Failed to lock. And we have to find a good. It's usually the root, right? Self root. Yeah. Self root join. Layout init lock. Failed to obtain lock for initializing layout. Do I have some name? Depths native build fingerprint examples root. No, not really. Yeah. And I think this will also provide me with a path at some point, right? Because any lock will fail with a path. It will tell me which log file couldn't be obtained. So that should be fine. Good. So here we have a log on the layout creation. Let's go back here. So this stuff uses the queue prepare init, which queues a lot of stuff, fingerprint stuff as well. But we have to, this way we have to lock the fingerprint functions, which are these. So we have basically two additional places. We have the log file stuff and the fingerprint stuff. And the log file stuff is done once per package, right? I have to, let's compile this right away. Let's see if it works. Nope, human. human. Yeah, so geez, we need a lot of locks for this. Yeah. Custom build, prepare. Anyway, so it's here we would get into the realm of fingerprints, and I would love to just lock a single thing, this entire package I want to lock. Prepare init, pkg, context prepared targets. This is what we have locked already now. Then we compile the targets. And it's always queued. So for each target profile, run the compiler or raster accordingly. After having done so, we enqueued the job in the right portion of the dependency graph and then move on to the next. This loop also takes care of enqueuing the work needed to actually run custom build commands as well. Okay, so that's the enqueuing thing. Yeah, so wait, let's not get ahead of ourselves. Compile target. So here we know that this is done. Prepare init will enqueue stuff. Calls itself recursively, okay. For each package, it creates these queues. Yes, yes, yes. And this is fingerprint, prepare init. This is where we have to lock up the structure. Damn it, didn't compile. Turned exit of field self config. Oh, the layout has no config, right? Okay, so I have to change my layout type now. Yeah, so we can't use a layout any. Oh no, we have a config. Look, we are still good. It just stored. No, we are not good because it's not stored. Okay, I forgot that. Good. So that's some refactoring going on now, which just has to go here. So new. Oh, damn it. Yeah, so let's provide a pubfn lock kind from config. So we take a config. Yeah, we don't store that anymore. And in any case, we produce a kind. Do we also produce an error? Yes, we can produce an error. So it's a cargo result with a lock kind. And this goes here now, the entire part. Well, why not? Even cleaner. Like this. And now we don't want to store that anymore. Maybe it should have been done like that. In any case, kind is lock kind. Let's get rid of this. We need that here now. Might be calling it A, as it's kind of more common now. And maybe we don't even need that. You know what? We don't even need that. Forget that. No need. Good. Cargo result lock kind. And this shall be an OK. Like this. Actually, I might just say, well, look at that. Isn't that better? That is better. No explicit return. And we have much more space now. Configuration key. Here. Better. Better. Much better. Cool. That looks better. Might have done that right away. Now we are here. So new. I think the caller will have to just provide a kind to us. Lock kind. And here we go. It will also be faster when accessing. Not that it would matter, but it's better. Kind is kind is kind. And then we use self-kind clone. Yeah, I think that's it. That is that. Yeah, looks good. Looks good to me anyway. Oh, but now if the user wants to obtain the lock kind, he has to do a dance to deal. Oh no, he can just try. That's fine. He can just try to get the lock kind and embed it right in the call to new. But we shall see how this looks like in the registry. Cargo lock new. We'd use it 1, 2, 3 thrice. So new, and then we have cargo lock kind from a config, and we try on it like that. Should be fine. Yeah, so that's the new code. I will just edit everywhere, assuming that this will be the right thing, even though probably there will be some subtle error that I didn't see coming. But yeah, in theory, this will now be fine. And the problem is that we have no access to the lock kind here, no matter. I mean, I think this is cleaner. I think this is better. But we still need information about the lock kind, and we only have it if we have